modeling using variation. The goal today is to solve direct, inverse, and joint variation problems. Telecommunications companies actually estimate the number of phone calls expected per day between two cities. And this is the formula they use. And this shows that the daily number of phone calls, C, increases as the population of the cities P1 and P2 in thousands increase, and decreases as the distance D between the cities increases. Variation shows how one quantity changes in relation to other quantities. There are two types of variation, direct variation and inverse variation. Direct variation is what we're going to start with. All of our variation problems will follow the same method. There's just one special thing you have to do different. So direct variation is what we're going to cover first. This right here is our formula that we're going to write for y varies directly as x. So anytime something varies directly as something else, the first thing goes here, the second thing goes here, and k is a non-zero constant. It's just a number. It's called the constant of variation. So here's a real-life example of direct variation. When you swim underwater, the pressure on your ears depends on the depth at which you are swimming. P equals 0.43 times D, where P is the pressure in pounds and D is the depth in feet. That's why when you swim deeper, your ears hurt. This 0.43, that's your constant of variation. So water pressure is a constant multiple of your underwater depth. Steps to solve variation problems, and this is going to work for every single variation problem you're going to get. So step 1 is write an equation that models the given English statement. And this is where it's going to be different for direct variation and for inverse variation and for joint variation. But for direct variation, we just went and did that on the last slide. It's y equals kx. Then, after you have that down, you're going to substitute the given pair of values in the equation in step 1, this equation here, and solve to figure out what k is. That's the constant of variation. Next, you will substitute the value of k that you got here into the equation you wrote here. Then, you're going to use the equation from this step to answer the problem's questions. And I know this seems kind of vague and abstract, so let's do an example. So also, this is really important. You might really need to know that. This is some important stuff. It's how we will solve all of them. Okay, solving a direct variation problem. The volume of blood B in a person's body varies directly as body weight W. A person who weighs 160 pounds has approximately 5 quarts of blood. Estimate the number of quarts of blood in a person who weighs 200 pounds. So, what do? Step 1, write an equation. So we're going to use this sentence right here, or part of a sentence, to figure out how to write our equation. We have varies directly. That's important to know because B varies directly as W. So B varies directly as W. That's the order you do it. Whatever comes first comes first. Whatever it varies directly with goes here. Okay, we have an equation. Step 1 is done. Step 2 is going to be in this next sentence, right after the sentence that says varies directly. We have a person who weighs 160 pounds has approximately 5 quarts of blood. So it says use given values to find K. Well, there's K, and in this sentence, we have a body weight and an amount of blood. So we plug those in. The amount of blood is 5, and the body weight is 160. So we have everything but K. Now we've got a simple algebra problem. K times 160, so we're going to divide by 160. And we get K is 0.03125. Okay? Now, step 3 says substitute the value K into the equation. Okay, so we're going to take this K and put it right here in this equation in number 1. And we get B equals this K times W. Now, finally, it says, step 4, answer the problem's questions. Well, where is the problem's question? Right there. Estimate the number of quarts of blood in a person who weighs 200 pounds. So we're estimating blood and we're given W. So B equals 0.03125 times 200, and we get 6.25. Now, with these, you can't just write 6.25 because that doesn't make any sense. So you have to say a 200-pound person has approximately 6 quarts of blood. And that's our final answer. But these 4 steps are going to stay the same no matter what we do. Let's move on. So, on your own, you're going to want to do this problem. See if you can get the same answer as me. The number of gallons of water W used when taking a shower varies directly as the time T in minutes in the shower. A shower lasting 5 minutes uses 30 gallons of water. How much water is used in a shower lasting 11 minutes? If you're paying the water bill, this becomes an important thing to keep track of. Let's give you a little hint. This is where step 1 will be found. This is where step 2 will be found. And this is where step 4 will be found. Now, pause the video and try to work this problem on your own. I'll be here when you get back. Okay, so step 1, W varies directly as the time T. So W equals K times T. That's step 1. Step 2, we plug in the 30 for the water and the 5 for the time, and we get 30 equals K times 5. We need to solve for K, so we get K equals 6. Step 3, we write the first equation with the 6 in for K. And step 4, we solve the problem, which is how much water is used in a shower lasting 11 minutes. Well, we're going to just stick 11 in for time. And we get the answer. A shower lasting 11 minutes takes 66 gallons of water. Did you get the same answer as I did? I hope so. Direct variation with powers. Remember that direct variation is y equals kx, and it can involve variables to higher powers. For example, if we have y can vary directly as x squared, then we write that as y equals k times x squared. If y can vary directly as x cubed, we write that as y equals k x cubed. You'll notice this is the same formula as regular variation with direct variation. All you're doing is substituting in. You got something to a power, you just put it right there. You don't leave the powers off or have to do anything fancy. So if y varies directly as the nth power of x, there exists some non-zero constant k such that y equals kx to the n. Okay? So let's solve one. Solving a direct variation with powers. So the distance s that a body falls from rest varies directly as the square of the time t of the fall. If skydivers fall 64 feet in 2 seconds, how far will they fall in 4.5 seconds? Well, step 1. Just like we had before, write an equation. That's going to be this sentence right here. The distance s that a body falls from rest varies directly as the square of time t. So s varies directly equals k times t squared because the square of t is t squared. Step 2, use the given values to find k. Well, let's look at that second sentence. We got 64 feet in 2 seconds. So 64 feet is the distance s, and 2 is the time. So we plug those in, and then we use that order of operations to solve this. So 2 squared is 4, and then we want the k by itself, so we got to divide by 4, and we get k equals 16. Step 3, we're just going to rewrite this first equation now that we've found out what k is, because it's a constant. So we get s equals 16 times t squared. And next we answer the question's problems. How far will they fall in 4.5 seconds? Plug the 4.5 in for t, do the arithmetic, and we end up with 324. Once again, 324 doesn't make a whole lot of sense until you put it in words. The body will fall 324 feet in 4.5 seconds. That's pretty fast, right? Here's another one for you to do on your own. Direct variation with powers. I'm going to read you through this and then pause the video and see if you can do this on your own. The weight of a great white shark varies directly as the cube of its length. A great white shark caught off Catalina Island, California, was 15 feet and weighed 2,025 pounds. What was the weight of the 25-foot-long shark in the novel Jaws? Okay, here's part 1, part 2, and part 4. Go ahead and pause your video. Okay, so the first thing we want to do is write that formula. So the weight, W, varies directly, so equals K times the cube of its length. That's L to the third power. So that's step 1, write the equation. Step 2, a great white shark caught off Catalina Island, California, was 15 feet and weighed 2,025 pounds. So we're sticking 2,025 in where weight was, and we are sticking 15 in where length is. And then from there, we go ahead, we raise the 15 to the third power, and then we divide it on both sides, and we get the k alone. So k equals 0.6. All right, step 3. We plug that 0.6 back into this original equation. So W equals 0.6 times L to the third. Then step 4, we answer the question. What was the weight of the 25-foot-long shark in the novel Jaws? Well, W equals 0.6. 25 is the length, so we're going to stick that in for L. So we have 0.6 times 25 to the third, which 25 to the third is 15,625. And if you multiply those two together, you'll get 9,375, which means your answer is the 25-foot shark in the novel Jaws would weigh 9,375 pounds. It would be time to buy a bigger boat. Inverse variation. All of the steps remain exactly the same except for which formula you put in step 1. For inverse variation, you're going to use y equals k divided by x. And the clue will be somewhere in the problem, it'll say something varies inversely as something else. Once again, k is still a constant variation. So in real life, the distance from San Francisco to LA is 420 miles. The time that it takes to drive from San Francisco to Los Angeles depends on the rate at which one drives, right? So time equals 420 divided by rate. 420 would be the constant of variation. All right, let's solve an inverse variation problem. Holy moly, look at all those words. Woo! This does not look as simple, but looks can be deceiving. Let's read through this, shall we? When you use a spray can, press the valve at the top. You decrease the pressure of the gas in the can. The decrease of the pressure causes the volume of the gas in the can to increase. Because the gas needs more room than is provided by the can, it expands in spray form through the small hole near the valve. In general, if the temperature is constant, the pressure P of a gas in a container varies inversely as the volume V of the container. The pressure of a gas sample in a container whose volume is 8 cubic inches is 12 pounds per square inch. If the sample expands to the volume of 12 cubic inches, what is the new pressure of the gas? It's important to note that this is not all about this problem. Like, we get a nice introduction to the generalized mechanics of a can of spray paint. So we don't actually need most of this. Our number one part is going to be way down here where it says the pressure P of a gas in a container varies inversely as the volume V of the container. This is just general fluffiness up here. It's interesting, but yeah, to do the math, we don't need any of this. So P of a gas in a container varies inversely as the volume V. So P varies inversely as V. So that's part one. We're going to write that right here. That's our formula. P equals K divided by V. Now everything else will follow the order of the steps that we did in the earlier part of this presentation. So the pressure of a gas sample in a container whose volume is 8 cubic inches is 12 pounds per square inch. So that's where we're going to get step 2. Use the given values to find K. They're right in there. So step 2 is 12 equals K divided by 8 because our volume is 8 and the pressure is 12. We want to get the 8 away from the K, so we're dividing, so we want to multiply. Multiply both sides by 8, and we get the K is 96. So step 3, we're going to substitute that 96 right in for K, and that's step 3. Step 4 is answer the problem's questions. So it's going to be that last sentence right there. If the sample expands to a volume of 22 cubic inches, what is the new pressure of the gas? Well, we're going to put 22 cubic inches for volume. So that's going to go down here. So P equals 96 divided by 22, which is 4.36364, and so on and so forth. So we say the pressure of the gas is approximately 4.36 psi, which is the fancy abbreviation for pounds per square inch. The steps are all the same. The only thing that changes is how this looks. This is inverse variation, and direct variation would be P equals K times V. So everything else stays the same in these problems. So let's do one on our own. Inverse variation. The length of a violin string varies inversely as the frequency of its vibrations. A violin string 8 inches long vibrates at a frequency of 640 cycles per second. What is the frequency of a 10-inch string? So let's give you some hints. There's where you find level 1. There's where you find step 2. And there's where you find step 4. Now, pause the video. We're going to come up with the answer. A 10-inch string has a frequency of 512 cycles per second. So we get that by saying, okay, in 1, it says the length of a violin string varies inversely as the frequency of its vibrations. So length varies inversely as the frequency of the vibrations. Then we do 2. A violin string 8 inches long vibrates at a frequency of 640 cycles per second. So they gave us the length and the frequency. So we need to find K, which is what we did here, and we found K is equal to 5,120. Then it asks, what is the frequency of a 10-inch string? Now here's where you have to be careful. Frequency is on the bottom, so it will take some serious wiggling to get this to come out right. So what you want to do is put K in for the K in problem 1. So L equals 5,120 over F. Then let's look and see what we're supposed to do next. What is the frequency of a 10-inch string? So we put 10 in for length, and that equals 51 divided by F. So what we do here is actually a little tricky. We times both sides by F to get F off the bottom of a fraction, because F on the bottom of a fraction is no good for us. So now we have 10F equals 5,120. We divide by 10, we end up with F all by itself equals 512. Okay? So combined variation is when the direct and inverse variations happen at the same time. For example, as the advertising budget A of a company increases, its monthly sales S also increase. Monthly sales vary directly as the advertising budget. So, that's our formula. Sales varies directly as A, which means that sales go up. Hey, the advertising budget just went up. By contrast, as the price of the company's product increases, its monthly sales S decreases. Monthly sales vary as the price of the product. So this is the formula. Yeah, inversely is not in there. You need to put it in there. So inverse proportion, S goes up, P goes down. So if you cut your prices, the amount you'll sell goes up. Okay, now we can combine these two variations into one combined equation. So remember, we have sales and advertising going up and product going down. The price of the product is going down. So we keep the S and the A on the top, and the P stays on the bottom. And then you have it all sorted out, and you can follow the steps exactly from here. So let's do an example. Solving a combined variation problem. Okay, so the owners of Rollerblades Plus determined that the monthly sales S varies directly as its advertising budget A and inversely as the price of the skates P. When $60,000 is spent on advertising and the price of the skates is $40, the monthly sales are 12,000 pairs of rollerblades. So first, we want to write an equation of variation that describes the situation, and then we want to determine the monthly sales if the amount of the advertising budget is increased to $70,000. So let's decode some of this. Step 1 is always going to be write your equation. So let's figure out this equation. We have S varies directly as its advertising budget A. So that means S is going up, A is going up, because when it varies directly, they go the same direction, and inversely as the price of the skate. So P is going down. So this is part 1. Step 1 of our process is to write the formula. So S equals K times A, because A is going up, these two are on the up, and divide by P. because P is inverse, so it's going down. Step 2, we use the next information. When $60,000 is spent on advertising and the price of the skates is $40, the monthly sales are $12,000, 12,000 pairs of rollerblades. So we have $60,000 for A, $40 for the price of the skates, that's going to be P, and the sales are 12,000 pairs of rollerblades. So let's fill that all in and solve. So we have 12,000 equals K times 60,000 over 40. Now, you can either multiply by 40 like I did, or you could reduce the fraction. But I felt like multiplying by 40. And then once we got 480,000, we divide by 60,000, we ended up with K equals 8. Step 2, we're going to rewrite this equation here and put 8 in for K. This right here is an equation of variation that describes this situation. So we have answered part A with this little formula, which is really just step 3. Then, step 4 is answer the question. Determine the monthly sales if the amount of advertising budget is increased to $70,000. And I'm assuming that we're keeping the cost of the skates the same. So we plug in our number, that's 70,000 for the advertising. And because they haven't told us a new cost for skates, that's what we're going to use. And let's see what happens to our sales. Do the math, we end up with 1,400. The monthly sales when the advertising budget is increased to 70,000 are 14,000. So I had written that wrong. Okay, are you ready for an on your own? Let's read through this problem. The number of minutes needed to solve an exercise set of variation problems varies directly as the number of problems and inversely as the number of people working to solve the problems. It takes 4 people 32 minutes to solve 16 problems. How many minutes will it take 8 people to solve 24 problems? So this is where we're going to get our information. It's also important to label because sometimes you can't have two P's and problems and people both start with P. This becomes a little problematic because it's annoying to have a large P and a small p as variables. So I broke it into minutes, M, varies directly as the number of problems, P, and inversely as the number of people. Being that math problems don't usually walk up to you on the street, I'm going to assume those people are students. Okay? So it's M goes up, P goes up, S goes down. Pause the video, see if you can figure it out. So that's how we write our formula. M equals K times big P over S. Then step 2, it takes 4 people 32 minutes to solve 16 problems. We plug those in. In this case, rather than multiply both sides by 4, I realize, hey, wait a minute, 16 is just 4 times 4. So I just canceled those. So 32 equals K times 4. Now we're going to divide by 4. We get K equals 8. So here's step 3. M equals 8P over S. Now we're going to use that formula to solve the problem. How many minutes will it take 8 people to solve 24 problems? So people is students, so that's where the 8 goes, where the S is. And P is problems, that's the 24. So we're going to plug those numbers in. The 8s will both cancel, and we're left with 24. It will take 8 people 24 minutes to solve 24 problems. That's it for today. Enjoy the rest of your afternoon.